Welcome. This video illustrates the concept of clean energy portfolio risk and why companies should go beyond the traditional spreadsheet analysis when selecting projects. Companies frequently use virtual power purchase agreements to procure clean energy. Let's say Company A is considering 3 PPA offers from developers for different projects. The 3 offers have the same delivery term but vary in location, technology, and price. The first offer is for a wind project located in the ERCOT wholesale market with a fixed price of $44 per megawatt hour. The second is for a solar project located in the MISO wholesale market with a fixed price of $62 per megawatt hour. And the third is for a wind project, also located in MISO, with a fixed price of $53 per megawatt hour. Company A must now determine the fair market value of the PPAs to understand its forecasted net spend for each transaction. A PPA's fair market value can be calculated using the fixed price of the PPA and the forecasted market price for the offer. The fixed price is what Company A would commit to pay the developer. The forecasted market price reflects what Company A would earn as revenue on a levelized hourly basis in the wholesale market. The fixed PPA price, cost, minus the forecasted market price, revenue, provides Company A's forecasted net spend on clean energy. Assuming Company A has market price forecasts, it will be able to determine its forecasted net spend for the 3 PPA offers. If the company contracts the wind PPA in ERCOT for a fixed price of $44 per megawatt hour and the forecasted market price is $38 per megawatt hour, Company A's forecasted net spend for renewable energy would be $6 per megawatt hour. In MISO, where the solar PPA fixed price is $62 per megawatt hour and the forecasted market price is $51 per megawatt hour, Company A's forecasted net spend would be $11 per megawatt hour. In the same market, a wind PPA with a fixed price of $53 per megawatt hour and a forecasted market price of $34 per megawatt hour would cost Company A $19 per megawatt hour in forecasted net spend. Based on this analysis, the ERCOT wind PPA is most cost-effective for Company A on a forecasted basis, while the MISO wind PPA would be the most expensive. If Company A primarily cares about forecasted cost, this analysis would suffice, and Company A would select the ERCOT wind project. There is, however, uncertainty in the net spend associated with a PPA. Although the price of the PPA is fixed over the lifetime of the contract, the wholesale market price fluctuates based on supply and demand, which are influenced by wind and solar output and commodity prices for natural gas and coal. If the market price fluctuates, Company A's net spend would fluctuate too. That means the net spend for each project is not a static number, but a probability distribution. For the ERCOT wind PPA, for instance, Company A could end up spending significantly more or less than $6 per megawatt hour. If we just compare the net spend probability distributions for all 3 projects, we see the ERCOT wind PPA distribution center is farthest left, with only a modestly wider distribution of outcomes. In other words, the ERCOT wind PPA would be most cost-effective for Company A on a forecasted net spend basis, without a significantly riskier profile. But if the company wants to consider its overall risk, it needs to factor in what it expects to spend on its electric load. Load refers to the total amount of electrical power that a company consumes at any given moment to operate its facilities, buildings, and electrical devices. Like a PPA, a company's forecasted load cost is a probability distribution, not a static number, because load is often linked to wholesale market prices. It's important to understand the relationship between the market price Company A pays for its load and the market price associated with its PPA. In an ideal world, the two would settle at the same price point so that when Company A pays more for its load because of higher market prices, the PPA revenue, which is also based on market prices, also increases and offsets the higher load cost. The more the 2 wholesale market price points are uncorrelated, the greater the risk for Company A. These charts illustrate the different levels of risk the company would take on a portfolio level with each PPA. While the ERCOT wind PPA has the lowest forecasted mean total cost, it also has the widest range of possible outcomes and therefore the most uncertainty. This is because wholesale market prices in ERCOT can vary widely from those in MISO. The MISO solar and wind PPAs, on the other hand, are in the same market as Company A's load, which makes their forecasted market prices more closely correlated to the company's forecasted load costs. Although they have higher means, their lower standard deviations indicate a far narrower distribution of outcomes, which reduces overall portfolio risk. Thus, the MISO wind PPA, while the most expensive by forecasted net total cost, is also the least risky option at a portfolio level. Each company will prioritize cost and risk differently. If a company has a high risk tolerance, it will primarily care about the x-axis. It's willing to take big risks to get the lowest possible cost. If the company is primarily risk averse, it will prioritize the y-axis. It'll pay a premium to know exactly what it's going to spend. Most organizations will fall somewhere in the middle. The key is to undertake a complete analysis of both PPA forecasted net spend and forecasted load spend. Otherwise, companies are procuring clean power without understanding potential risks. Without power market expertise and historical and forecasted data, this kind of analysis can be very difficult. Versus ARIA platform draws on industry-leading expertise, proprietary datasets, and analytical models to run analysis in a matter of minutes, saving you significant time and money. Contact us for a demo today.